great to see everybody here after 2 years of lockdown and COVID. And it's nice to be able to get to see old friends and colleagues again.
Doesn't it?
If we all jumped in the lifeboat, it's okay.
So, firstly,
We are working our way.
That's another sort of energy sustainable technology that sort of is great but works against us. It also burns the grass in my yard.
Three great presentations that we have had, and I'm going to start with an apology to my colleague who have worked on this presentation for me, that I'm going to deviate from the script because I want to get in line with the three fantastic presentations that we have already had. As you can see, I'm here to give you a global perspective. Apart from the miles that I would have collected with Emirates, I traveled 14 different countries. The best part that I have had in the last 7 years is to go through 14 different codes and standards and compliances for different building regs for fire. And what I would be able to share with you today is something very particular or be specific in relation to facades. And we have some fantastic standards, fantastic codes written already, but what we see is how do we implement. And my takeaway from Maria's presentation is to say that I've had questions, why do we need to do a compartmentalization for a fin, for an external facade fin? But we have extensive reports here today to show that you need to compartmentalize. We also have from the professor to say that the different standards work differently, products perform differently to different standards, and if you test on a Monday and on a Tuesday, the results might be different if it's installed with two different people. And another bigger challenge that I've seen is testing internal and testing outsides have also given different results. So I hopefully would go back to some fundamentals and basics, and we'll take it up from there on how we go. Three slides which I want to get away very quickly. I represent Siderise, so they have given me the platform, and for the last 8 years I have been able to go around the world and talk to various stakeholders in the industry and understand building facades and regs and contribute towards or share whatever I have in one country with another country to say that we build the codes together. Again, our basic focus has been in relation to facade, apart from a few other products that we do in relation to acoustics. But we go back and say acoustics, for example, is a comfort, but fire compartmentalization is a necessity today. So we all collectively have to make sure that we are able to send out that message, communicate the right message in relation to compartmentalization and in relation to fire safety and in relation to building a fire safe facade. Okay, again, a global. Why I'm here today is to give a global perspective. I sit in Dubai office, but go to around 14 different countries, work with 14 different authorities having jurisdictions. So would be able to share different standards that I would have tested the products, or as you can see, 250 plus system tests of the repeated products, repeated tests, but have been given different results where we can see how we can work on a research together. So 3 slides. That's sorry about that. One of the slide. This is a particular slide that I use in developing countries, or even a developed country like Australia, for example. If you have a project which has an active system in place, a building which has an active sprinkler system, you don't have to consider compartmentalization on a facade. It's written in the standard, and which surprises me. So there are people who follow those standards in another country where you don't have codes. So what I would like to see in the future, or with or a document to say that irrespective of irrespective of having active systems and projects, compartmentalization should be important, because it gives time for the occupants to exit the building. It gives safer support, or it gives support for firefighters to make sure that they are able to come in and secure the building, or make it safer. So going back to some fundamentals, we have some great standards, whether it's ASTM, be it EN, DIN, multiple standards, but two of the main interpretations that I come across, people say, oh, this is a fire rated product, this is a fire retardant product, and it's not good enough. Those terminologies are not good. We have to go to understand reaction to fire and resistance to fire. These are the main terminologies that we will have to use, so that we are able to convey the right standard, right message, or what the product exactly performs. So basically, when you say reaction to fire, how a component works when it comes in direct contact with fire, and resistance is how they work as a system to provide or to utilize the performance that you are intending to use. For example, if you can take wood, it can be considered combustible. It will, but if you use you can have a wooden fire rated door, and that's a system for you, for example. So reaction and resistance is something that we have to differentiate and communicate rightly to the audience who are selecting, or the stakeholders who are being working on the projects. Again, within reaction to fire, we have various ratings. Countries like in India, for example, what we use is a A2 panel. But if you go into Malaysia, the facade consultants like to use a B1 panel. And it's surprising. So when you go and ask them, why do you use not a superior product like A2, they say that it's because of the performance of the product. It might be fire is good with A2, but we have challenges with delamination, and we might have challenges with fabrication of the panel. So we would prefer to go with B1 instead of A2. So again, a different kind of approach in relation to selection of material, which should also be identified, and that's not the timer, I hope. So that's something that we need to understand and communicate. And when we say resistance to fire, again, it's all about 30 minutes. It should be in minutes. It should say compartmentalization. So if you are having a wall which is of 1 hour, then it should be 30 minutes, 60 minutes. So compartmentalization should be based on ratings or resistance ratings that you should get. Going into reaction, staying with facades, staying with the same subject of external facade assemblies and the test that we would have carried out. We have countries, for example, if you do a test for a 1530.1 in Australia, you don't have to do a large scale system test. So for example, if you do a solid aluminium, you don't have to do a large scale system test for projects, or you don't need any certification, and you can just pick the material out of shelf, which is again a surprise. You also have we have fantastic BS 8414. We utilize them extensively in today's market in UAE, in the UK, but also extended into various countries like New Zealand or be it Australia. There are standards that refer back to BS 8414 to help fire engineers, to help assessment peoples. We have the BS 9414, which tells, it's a very good document to say that, oh, okay, you have tested X, but what you can use and how you can interpret what you have tested. So whether you can replace an insulation, for example, yes or no, or whether you can replace the size of the panels, yes or no, whether you can change the cavity size, yes or no. So it's all documented in BS 9414, which we can use when we are choosing the right system for the project. Interestingly, we also have LPS. So Malaysia uses a combination of tests. Singapore sticks with the NFPA 285. when it comes to facade, but when it comes to curtain wall, they use an ASTM standard, which is again derived within the Singapore Civil Defence codes. So I'm referring back to extract from the UAE Fire and Life Safety Code, for example. A very good standard, very good code. It explains what is the type of building and what is the material that you can use in that particular segment, what are the tests that you require, and whether it's a component test or if it's a system test. It's very well explained. So you go back, I was introduced that I'm from India, but we have had 2 fires in last 10 days in India. Both are public occupant buildings. So one of them was a shopping mall in Delhi where we lost 27 valuable lives, and another one was a hospital. You can understand, I can't even imagine the trauma that the occupants in an hospital would have gone through when they are sitting. They have come for saving their lives to the hospital, but still the building is not safe. So a standard like this in UAE, for example, though even your hospital might be a low-rise building, you still have to use, they tell you what types of cladding that you can use, which is very important. So we cannot, it has to be documented to say this is what you can use. So if there is authorities having jurisdictions if they can mandate it, then I think we are one step away from one step safer towards putting a good building together, or a safe building. Again, I don't want to spend time on this. It's about, even if we are saying fire resistance, then we have a gray area about integrity and insulation. So where a product might work very well as integrity, but when you put it as a system, they might not achieve an insulation value, which then again can ignite some other material if your insulation is not well, or the insulation property is not good. Or we might have conditions where because of insulation failure, you might have a totally different challenge of integrity failure. So it's very important that we follow the compartmentation formula where the primary fire and life safety strategy for the building is written based on what is a fire rated wall and what is the compartmentalization performance that we should look for. One more terminology that I have always seen that it is different in various countries is to understand what is a cavity barrier and what is a fire stop. So when we are using a curtain wall application, people still classify that as a cavity barrier, but ideally it's a line of compartmentalization. So we have 3 different challenges in facade. One is internal, which will be as a internal spread of fire when you have a curtain wall arrangement, or an external spread of fire when you have a rain screen facade. So these are the 2 different requirements or considerations that we should have on a facade arrangement. Again, a better image for you. So a perimeter barrier would be an internal spread of fire, and cavity barriers would be an external to stop the external spread of fire. So these are again different terminologies, and it has to be defined very well within the documents that we as engineers put together for stakeholders on a building when we are constructing a building. So I'll still stick with compartmentalization for internal spread. Again, when you have fire on a curtain wall arrangement, you have spread of fire through the void between the floor slab and the external facade assembly. So you also, there are standards now, for example, in the ASTM standard, you have a new standard which has been put together to assess how the spandrel zone should perform, how the spandrel should remain in place, so that you don't have a leapfrog effect where a fire might go through the vision area and come back inside through to the higher floor. So that's also a consideration now which is being evaluated, and there are test standards to which products can be tested, and it can be derived on a performance. So there are various, again, going into Malaysia or Australia, for example, they use standards. For example, a BS 476 Part 20 is a very commonly used number for all of us, but these are not standards right for the application, or are these right applications? No. So the standards have evolved. We have within the EN standard, we have where we can use the same configuration where we would be using the materials or installing the materials on the project, or we also have the ASTM standard again to say that you can test to the same configuration that you would be installing on a project. So you don't require any desktop studies or assessments where you do a different test and then see that the material might be used for a different application. So you're not required to do that. You can get raw data from the tests that are available or standards that are available.
Tall Building Fire Safety Network delivers high-quality safety management training for anyone involved in the fire risk management of high-rise or tall buildings. Recognised by the Institution of Fire Engineers, we've been delivering fire safety training since 2011, and many organisations rely on our training for gaining competence in this field. Sign up for our training courses and conferences in 2023.
So again, sticking with curtain wall, just to show an image to say that how these tests are done. So use the full assembly data information, or you install the full assembly to check the performance of the facade for fire for the resistance period that you are looking, or even an EN data to say that what's the performance and what are the components that you have used and how you can interpret that with the project utilization. Again, talking about characteristics of the product, these standards have now evolved. You also have the requirements of building movement. Within the building movement, I mean, what we are installing today, we don't want, the fires might happen today or to the cycle of the building, which might be 30 or 40 years later, and environment is changing. We had rain in Dubai in March, so the climate is changing. So we don't know how it's going to be 30 years or 40 years. So you test the products to the worst conditions so that you can use the right product and right information or data to utilize it on your projects. So movement is something which is very important, where you select where we select the products to the right application of the building movement through the years that can come across, and then you test the same product for an assessment. Test the same product to the standards where you can assess the performance of the product. Another thing that developing countries are lacking in and where we can improve is certification. So I'm very happy to share this stage with Abhishek, who's going to be the next speaker coming from the same industry or same subject that we talk every day. Certification is something important. What we do today or what we test today should be accredited by a third party to say that you are doing the right product, you are continuing to manufacture the same product to the right test standards that you have tested, and you are continuing to supply. So projects, for example, it's not a mandate requirement in Australia, which is a very developed country. It's not required in Malaysia, for example, or in India. We don't even know what is certification of a product. So that's something that we have to go through. The process is very well defined in developed countries, and this is something that we can take it forward. And when we talk to stakeholders in different countries or developing countries, we can, through authorities having jurisdictions, we can still say that we want to mandate certification, and we want a third party to accredit what we are testing or what a manufacturer is giving. Again, test for the future. today the laboratories are very flexible. They are able to give us test rigs for R&D purpose. So a test for the future, see if you are having a very unique condition on a project, learn from it and test for the future. For example, test for the, if you are having a large void, test for a larger void. If you are having an inclined facade, see the possibility of testing for it, because as Maria presented, the performance of a product or the facade might differ if you are having a very different geometry of the building facade. So test for the future, consider what are the various combinations that can be there on a project, and utilize them and get a test report. So I want to give a cycle of a project that I was involved in my short career or experience that I've had. This is a project where we did or I worked with on a Dubai DMCC, where the developer is a DMCC. Very fortunate to work with architects like Adrian Smith and consultants like WSPs for Façade. So this project started in 2013, where it went into the drawing board, where the client or the developer said that we are going to do this project. And then once the design approvals or the architect's intent or the initial details came, we were engaged in 2017 by the contractor. This is one of the first few projects in Dubai where the main contractor is the facade contractor. It's very, it's not a common practice in the part of world where I'm coming from, but we were engaged in 2017, and the data that we had for the product was nowhere what the project required. So then it helped us to go back to the drawing room to see what the regulatory requirements were, and the UAE Fire and Life Safety Code is an evolving document where we knew what were the changes, what we can expect, or what the future will hold, or what improvements that we can make. So we were able to go into a phase where we were able to test for the future, and we started planning in Q3 of 2019. Installations, a very difficult period due to COVID, but 2020 the installation started. But what we have today is a fantastic building of 340 meters height. In a very short duration, we were able to, if the planning is correct, if the involvement of stakeholders are at the right time, at the initial time, you can execute a project in a short time, and build a safer building today. So fantastic building, fantastic set out with the background. I'll just wait for 10 more seconds to show you what's the background of the skyline of Dubai, where again, we have projects. Remediation is the biggest challenge. We have had projects which are built in 2011. A client comes and says that, oh, we didn't have the regulation in 2011 and we are not able to upgrade. It's a cost. So who's going to take the cost? You see the skyline of Dubai on the backside, which is called as Jumeirah Lake Towers. There are around 100 towers where you can point to say that these were cladding materials which were installed in 2011. And 3 of the fires from Dubai, which was highlighted on a previous research paper by Maria, are on the same location. So we have buildings which are next to each other, which have not the right cladding material which we know, but still there are no jurisdictions or mandates to say this is how you have to change. Another project where we have where an early engagement helps, again data from what earlier speaker presented was a vertical fin. People keep asking me, why do you have to compartmentalize a fin? But it's very important looking at how the fire would spread, looking at the source of fire that you have adjacent to the fin. So what you do is you compartmentalize. If you're not able to, if it's very difficult detail, you have the opportunity to sit with the manufacturers, detail a right compartmentation product that can be utilized, that can be designed, that can be installed so it can look good in paper, but it has to be installed by us effectively. So it's important. So what you do is go back to the drawing room, and with manufacturer's support, you could do various options and then get a system in place to compartmentalize. There is nothing that we cannot do or a manufacturer cannot do. They would, we as manufactured or any other manufacturer in the industry would be looking forward to going back to the drawing room and seeing that let's test and do it. So this is one of the cases where we did a very unique facade, unique fin. We manufactured a cavity barrier in the same shape, so the architect intent is kept and still compartmentalized effectively. So again, early engagement from stakeholders and manufacturers from every phase of the project is very important. We are facing challenges in relation to supply of materials with logistics. Post-COVID, it's becoming a very big challenge. One of the reasons why I like this platform is from the UK, there are lots of manufacturers who supply to the world. So, we have to comply with regional codes. We have to educate ourselves to make sure that we are able to comply with the regional global codes and standards and see or extend the best practice that we are following in a country which is regulated. So again, a very quick 6 steps to building a safer building in line with what Brian had presented earlier. So good design is important. Buildability and the quality of of the product. So it has to be buildable. It's not only on the drawings or not only on the table, but it has to be buildable. Programming planned correctly. So we have had projects which had started and we couldn't get the material across, but because of timeline they will have to compensate with alternate materials, which is a challenge. Selection of materials, not only because all the aspects has to go in, architectural intent and fire safety, everything should be collectively judged. Site management to make sure that we document it, we give the right quality of installation or supervise the quality of installation, but site management with right training tools for the installers is important. One of the other challenges is human interference. So we all sit in a very good cabin today, but the people who are installing in developing countries, for example, in India or Malaysia, for example, they totally don't, they speak different language, so they don't understand what we are doing. So communication is important through quality and site management that we are able to go through. And finally, assess what went well, so that you are able to improve. What was not optimal, what was not the right application for the project, and then what are the lessons learned is something which is very important. And then future, what you can do, document it rightly. You have technologies today that you can support stakeholders to understand what is going to be the outcome of the project. You can provide digital documentations. You can provide QR codes, for example, today on products, so that 30 or 40 years later, you are able to see who the manufacturer or the provider of the product was. Or even you can include whatever you're doing today on a third-party app and put it into a cloud which can be used or seen 30 or 40 years later. So if we are able to do that today, future generations can really be, it would be easy for the future generations to adopt. So that's it. Thank you very much. And thank you for the opportunity here.